Hi, warm welcome to today's video. Let's start a new day. So yesterday you learned how to create graphical user interfaces using a Python library such as Free Simple GUI. That was a third-party library. So you learned that you can install these kinds of libraries either using this Python packages section here or by opening the terminal and writing pip install the name of the package, and once you install that package you can import it as we do here. So what you're importing is a bunch of Python files basically, and then you use the code of those files in here. So we import free simple GUI SSG, and then we use the text class which creates a text object on the interface. So this is what we built, basically. This is very simple, but it does have a couple of widgets, such as this text, which I showed you. And then we have the input text, this area here where the user enters the to-dos. And then we have this button. And then we have this window object. So the window object is what wraps up all the widgets. It's basically the interface itself. So once you create that object there, then you read it using the read method. And then when the user closes the window, then this method will execute. With that, we're ready to develop this script even further. So I'll see you in the next videos. Hi, today you're going to go deeper into understanding how desktop computer programs actually work and how to make them. Exactly, we're going to do two things today. First, we're going to make this window bigger, all the fonts, all the buttons, the text boxes, it's going to look bigger. And then the second thing is we're going to implement this add button. So if the user enters a to-do here and they press a button, that to-do item is going to be stored in the todos.txt file. So let's do this. This window, as you know, it is produced by this GUI.py file. For those who are using Git, make sure that if you click on Git here on this tab, make sure that these two tags are set on the latest commit. So if one of these tags is in the previous commits, then you want to right click here and then go to checkout and then checkout master. In my case this is fine, so I'm not doing anything. In your case I also suppose this is also like this, but if you have been playing around with checking out different commits, you might have forgotten and you might be checked out in a previous commit. So you want to be checked out in the latest commit, so you have the latest version of your program. That makes sure that we are actually developing the latest version of the program and not a previous version. Let's begin. Go to window, which has this argument, this other argument, so it has two arguments currently. We're going to add a third argument, so go to the end here. So just before the closing parenthesis you want to put a comma, and then you should say font is equal to a tuple. Maybe a space here, remove that space. So this tuple should contain two elements. A string, which should specify a font family, and a font size, which should be a number. So 20 I think is fine, a size of 20 for the font. Now what I'm going to do actually is I'm going to have these arguments each in one line. So after my to-do app and after the comma, just here after the space, coming after the comma, I want to press enter to split that line into multiple lines, and that is syntactically fine. And I'll do the same for the other argument. So before font, I want to split it. I'm doing this because this line is getting too long, so it's better to have around 79 characters for one line. So that is the recommended length of Python code line. 79 means 1, 2, 3, 5, 6, and so on, up to 17. That's a recommended size unless you have a good reason not to keep that recommendation. For example, when I'm doing videos here, I'm interested to show you as many lines of code as possible. Therefore, I can let some lines be longer horizontally so that I can show you more lines vertically. But generally, the recommendation is 79 characters. The reason for that is to also be able to show several files in a split view. For example, if I right click over functions and I open it in right split, and so I am able to see both files by keeping that 79 long character limit. So that's the idea. Let me close that, we don't need to see it right now. So let me run the code, GUI.py, and that's the output. So it's looking better. Next, this is what we're going to do. Whenever the user enters something here, like buy grocery, and we press add, we're going to store that into those.txt. What happens when we press add right now? This is what happens. Everything under .read is executed. So what is window.read anyway? So this is a method, but usually methods return something. Not all the time, but this method does return something. So let's store that output in a variable. Let's call this variable event. And then I'm going to print out the event variable down here. And I'm going to run the code again. Let's say just hi, to keep it short. And we've got something. So it's a tuple. You see it's wrapped in parentheses. So any instance wrapped in parentheses is a tuple. Well, these are not tuples, by the way, so that those are parentheses for instances or functions. So when the parentheses are connected to a name, that is not a tuple. When the parentheses are individual, such as these ones in here, so they don't have a name in here, that means that is a tuple. And this tuple contains one item here and another item in here. This first item is the label of the button. And this other item is a dictionary. It contains 0 as the key and hi as the value. Hi is what we entered in that text box. And 0 is the key of hi. Actually, we can change this 0 if we go to the input box instance and we add another argument here. So after tooltip we add key is equal to, let's say, to do. Let's run again, run GUI, write hi again, press add. So now you see that to do is the key of that. So basically what we got here is information about the event that happened. The event was, as you saw, getting a value in the input box and pressing the button. So that's what we get here. We get the first one, which is a label of the button, and then the information about the input box. So it says that the to-do input box, input text instance was having a value, and that is the value of that instance. So this allows us now to get these two values and store them into do's.txt. But a better way to have this variable is to actually create two variables, event and values. And then print event first and then print values and see what's going to happen. Let me stop it because it's not showing and run again. Sometimes you have to quit the app among your programs and run again. Right, let's try hi again. Press add and we get add for the event and this dictionary for values. So basically what we did here is xy, which is creating two variables in one single line, and then we have a tuple with two elements. So one element first and two elements, and so x will get the value of 3 and y will get the value of 4. So same happened in here. Event gets the value of add, the first item of that tuple, and values get the value of this dictionary. Because actually the press of a button is an event, so event is getting the label of the button which was pressed, and the values variable is getting the values that were filled by the user. So now you know that it is possible to assign two variables at the same time to a tuple or a list which has that number of items. So two variables, a tuple with two items or a list with two items, etc. Now the next problem we need to solve is the program closing. When we press that add button, we don't want the program to be closed, so let's fix that. Well, the easy way to fix it is to add a while loop, while true, and just indent that read method under the while true loop. Let's also indent print event and print values under the while loop, but don't indent window.close. The window is closed after the while loop ends. So let's check now. Run GUI, hi, add, we get the print thing here, right? But the window is still open, it didn't close. So you can keep on using your program as a user. Press add, again it says that the add button was pressed and this hello value was received from the to-do input box. So to-do is the ID of that input box. It is how the program identifies that instance now, and that's why we set here to do. So whatever value you give here, it's going to be shown in here. And that is the while loop, which keeps the window open, so it reads it over and over again. Every event that happens creates another run of the loop. So therefore, while true is always true, therefore the loops will happen over and over again. And now we are ready to add some match event case add and do something if we have an add case for event. So you see that anytime we had an event printed out, add, and so on. And later on we're going to add more buttons, such as an edit button. So we might have an edit event and a complete button. We might have a complete event. Therefore, we're going to have match event. In case it is an add event, do something. In case it is an edit event, do something else, and so on. So if it is an add event, we're going to get the to-dos from the functions module, which I'm importing up here. So import functions, and then functions.getToDos will, let me split this on the right, will call this function, and that function gives us the list of the to-dos. So this function reads that to-dos.txt file and gets that list from there and returns it to us. So to-dos is going to be equal to the list of the to-dos. Now in this file path I have this to-dos underscore item. I'll change it to to-dos.txt to reflect my to-dos.txt file, so make sure you have that right as well in your computer. So once I have the to-dos, then I say to-dos dot append to add the new to-do. But which is the new to-do? Well, the new to-do is values to do. So values is this variable, and that variable represents this dictionary. And with that syntax, values to do, we get that high value. So we get the value of the to-do key. So this is a dictionary of a key and a value, and values to do gives us that value of the to-do key, right? Then we append new to-do to the to-dos list. And then functions dot write to-dos. So I'm calling that function which expects this to-dos argument. So that's a to-dos list, this list now, which has this new to-do added on top of it, at the end of it actually. So the new list is going to be written in the file. Here, be careful, you might want to add plus \n, a break line, so the user enters the to-do without a break line. Therefore, we want to add a break line so that each to-do is in a separate line. And that's it. So let's try this. Run GUI. I had to quit the program first and run it again. Let's say master Python add. We get this printed out and that one as well. So let's check to-dos.txt now. And here we go. Master Python is part of the to-dos list. So it's working. Now, let me bring back the program. If I press this button, you're going to see these errors. So maybe you want to kill the application, and we want to fix that error now. So go again to GUI.py, and what you want to do is add another case. So case, which is indented in the same level with the other case add. Here this one is going to be sg.win closed. So what is sg and what is win closed? Well, sg is the module PySimple GUI, and window close, win close. If you right click here and go to implementations, you're going to see that this is a variable defined in the PySimple GUI files. So this variable is then used somewhere else in here. and this variable is going to get some dynamic values which specify if the window is closed or not. So if that is the case, if this gets a true value, then we want to break the while loop. So break is a statement related to the while loop. And this case happens when we press that red button. So when we press that button, then we don't get that error anymore, so the program finishes correctly. Later on, we're going to add an exit button as well, so we can use that exit button also to close the program. But for now, let's just use this button. So that is the final program. I want to commit my changes now. So everything looks okay, it's working. Therefore, I want to go to the git commit button up here, press that button, and we want to create a new commit message. So what did we just do? What did we develop? Was it a new feature? Was it some changes? Well, we added a new feature. We implemented the add button. So press commit. And then you can also do a push operation, a git push, to upload your changes, your files to GitHub, to synchronize your project with GitHub. But I usually do this by the end of the day once I've done several commits, so I wouldn't do this now. We have one more video to go, so after that video we can do a push to GitHub. So with that, thank you for following, see you later. In the previous video we implemented the add buttons, so anything we write here and we press that button, that string goes inside todos.txt, you see? Now in this video we want to implement an edit button. But how would that work? Remember that when we were using the CLI file, previously known as main.py, so the command line interface, we used to edit a to-do using the edit and then give the number, the index of that to-do items. That worked, but it was not very user-friendly. So this time we're going to find a better solution, because graphical user interfaces allow us to create more user-friendly interfaces. So what we will be doing is, let me show again. First, we're going to display all the existing to-dos somewhere below this input box. And then on the side of the list of the to-dos, we're going to add an edit button. So first, let's display the to-do items. What we want to do is we want to change the layout of the window. So anytime you want to add some new features, that means you want to change this layout argument to add a new element to it. So currently we have the label in one row, and then after that we have this other row. So every list, this list is a row, that list is a row of 2 elements. So now we want to add a third row. And this row is going to contain 2 elements, 1 here and 2 here. So 2 instances, 2 different types of objects. The first is going to be a list box. So that is the instance, that is a variable. The values of this list box will be the to-dos. Now this expects a list, so you can write the to-dos here, like buy groceries, etc. You can hard code them, but that's of course not a good idea. So we want to get the list automatically using functions that get to-dos. So we use that module, and that function gives us the list of the to-dos. That function gets that list from to-dos.txt. So we're talking about this function. So just to be clear, you know what I'm doing. Right, we have a list here. We give it to the values argument of the list box instance. Else, this also will need a key to identify that list box. Let's say items or to-dos. So this is a different key from that. Don't use the same key. The input box has this to-do key, the to-do that the user enters in the input box, and this is a list of existing to-dos. You also want to enable events. So this is an argument which expects true or false as argument, so a boolean value. And since this is getting long, I want to split it here and then add one last argument, the size, which expects a list. This is going to be the size of the list box. You're going to see how it displays. So that's the list box, and then we want an edit button. We're going to use the same type. So button is the type, but then this is the instance. So that instance is different from that instance. Both have the button type, both come from the button blueprint, but this has an edit label, that one has an add label. So now list box and edit button go here. List box and edit button. With that, we can run GUI.py. Let's look at the errors. Attribute error. Free simple GUI has no attribute list box. Did you mean list box? Yes, that's what I meant. So we go here in line 7 and we change list box from capital to lowercase b. And run GUI again. And there we go. So these are the to-do items. You see that whenever we click one, something is printed out in here, down here. So let's click on buy grocery, and that's what we get when we clicked on buy grocery. So we get a dictionary. This dictionary has this key which is associated to that value. So to do is the key of this input text. So if you write something here, like example, and then click something, then you get that example. So to do corresponds to the value of the input box. And then we have this other pair of key for that dictionary. The key here is the key for the list box, right? So whatever the user does here, that is recorded in the event and the values variables. So event is to-dos, and this is the values variable, that values, which is a dictionary. So that means to-dos, the list box to-dos has that value currently. So the user has selected that value by the painting. So with that in mind, we can now go to the while true loop. and add a case edit below case add. Case edit, so let's double check the label of the button. Yeah, it's edit. It was add for that add button, and it's edit with uppercase E. No. So we're checking the event. If you remember that, the event is this one in here. Currently though, the event is to-dos, because we still haven't pressed that edit button. But if we press edit now, the event is going to be edit, you see? So when that happens, then we want to first get the to-do that the user selected. So let's get it in the to-do variable. So what that would be is values. So that is values, right? The dictionary is values, which we printed from here. So we're aiming to get that part. That means we point to the to-dos key, and that will give us that value. I can also enter here print values to do, so you know that we're actually getting that list. And I'll run the GUI again, select clean the code, and press edit. And this is what we get. We got these printed out when I pressed on edit. Or to be more clear, I'll write here 1, 2, and 3 and run again. Press on clean the code again, and now it's more clear what is being printed out. So we get to-dos for the event, the values dictionary for values, and the list for that port. So that is a list, right? Therefore, to get the actual string, we want to write 0 here. That will give us only the string. So we got the to-do from the user, the to-do they want to edit. You can also change that variable to-do to edit to be more clear. Then you want to get the new to-do from the user. Where do we find that? Well, let's run again the code, but let me comment this out because we get a syntax error since the variable declaration was not complete. So let's run again. If the user writes something here and they select one existing to do and they press edit, then something is stored in here. So we want to get that value now. Therefore, that value is going to be equal to values, so it's inside the values dictionary. And try to guess how we get that? Well, using the to-do key. That should give us something. Alright, so we have the existing to-do and we have the new to-do. Next, we want to get the current to-dos from functions.getToDos. And then we want to replace the existing to-do with the new to-do. So how do we replace an existing item in a list? Well, first we would point to todos.index and get the index of the to-do to edit and store that index in variable. So for example, if the user selected clean the code, this expression is going to give us the index of clean the code. And then we say to-dos, the to-do with that index which is clean the code, so that is clean the code. Clean the code is going to be replaced with new to do. And then we say functions.write to do. And we write the updated to-dos list. So this expression is going to update the to-dos list with the new to-do, replacing the existing to-do. And then we write that list to the to-dos.txt file, because write to-dos actually modifies that to-dos.txt file. That's what we do here. So let me run the script. Let's say we want to edit new order with good order, right? Press on edit. Now new order is still displayed in here. However, if we open to-dos.txt, we see that good order has replaced new order. We do have this problem though, that this has been merged with the to-do item below it, but we can fix that. And we can also fix the issue that new order is still here. Now new order of course is going to be refreshed if we close the program and we run it again, GUI.py. So new order is disappearing, but we want that in real time. To do that in real time, what we need to do is we go inside case edit, and at the end here, after we write the to-dos in the to-dos.txt file, then we want to say window, and we point to the list box key, which is to-dos, so that will give us the list box instance. Window, as you know, is this instance, so window contains all these instances. It's like the mother instance, and with this we access the list box of Windows. And then we say .update. So update is a method of the list box. And then we say update values with to-dos. So the existing values of the list box are going to be updated with this list. So the list at this point is updated with a new to-do, because we change the new to-do, we place the new to-do in the list here, so therefore we have an updated list. Let's run again. Let's try to change by grocery, so I'll select that, let's say by plants, press on edit, and you see that by plants is now updated down here. Similarly, we can update this. Whenever we select something, we want this to show that selection instead of staying by plants all the time. But how do we do that? Well, you should notice here in the command line that whenever we select, for example, clean the code, you see that the event is to-dos. So that has the key of the list box. Therefore, here in match case, we want to capture that case to-dos. So if that's the event, which is when the user selects something, we get a listbox event, to-dos, then we say window, and we point to the input box, input text instance, so which is this input box here, and that has a key to do. So we say here window to do dot update, value, not values. This has an argument value, this method. And as a value, we say values. We want to set here the current value. The current value is this one in here. That's what the user selects, which is part of to-dos. That key. So values is the dictionary, remember, that dictionary. And this will give us that list. And then we want to extract the string. The string has an index of 0, since it is the only item of that list. So that should update the current selection and place that current selection in the input text box. We hope so. Let's try. Run GUI, select clean the code, buy the painting, and it seems to be working. Yep. Let's try to edit clean the code to clean the program. Press on edit, and it replaces that successfully. Go to to-dos. So there we go, clean the program. Let's add a new to-do. My newest to-do is added. Press on add. Check to-dos. Yeah, here we go. My newest to-do is added. PyCharm highlights this in yellow because it thinks that this is a PyCharm to-do, which is a feature of PyCharm. That's another story. But just wanted to tell you that don't be surprised why this is in yellow. And now, we also want the list to be updated when we add a new to-do, right? Last to-do, add. We want that last to-do to be added in here in real time. So let's implement that as well, and we're done with this video. So that is in add. When add happens, we want to do the same thing we did with the edit case. So we copy that expression and we add it here. That means we point to the listbox instance and we point to the method update of that listbox instance, and then we say values are going to be equal to the to-dos, the updated to-dos. The updated to-dos are going to have this new to-do added. So let's try this feature. And lastly, add, and lastly is here. So there we go. Yeah, it seems to be working fine. With that, I'll close this. We're going to fix that error later on, so don't worry about that. And I'll commit. This is going to be implement the edit button. This gives us a warning. As I told you, PyCharm has this feature that whenever it finds something written to do, which is in our text file, to do here, to do there, PyCharm thinks that we have written some PyCharm to-dos, so it warns us, hey, you have something incomplete, maybe you want to do that first. That's not the case here because we meant to say something else with these words, so I'll commit anyway, press that commit anyway button. And yeah, I'm going to push these two last commits. So these are the commits that have not been pushed to GitHub. Therefore, I'm going to push them, and if I refresh GitHub now, you're going to see that these files, gui.py and todos.txt, were just committed 23 seconds ago. So I committed them, and therefore these are the latest versions now. These other files were committed before, and we didn't do any changes to these now. Therefore, this implement edit button commit didn't affect those files, since they were not changed. And that was the video for today. Thanks a lot, I'll see you later. Today we're going to run two different experiments. One is related to the break statement. So the first experiment will give you a better understanding of the break statement. The second experiment is related to the layout argument. So let's begin with the first one. This is the existing code we built so far. So at the end of the code, we have this case SG when closed break. And then we have window.close. Now, if I add a print by function just above the window.close statement outside the while loop, you see this is unindented. It is in the same level with window.close. If I run the program now and then I press this button, so let me show you the code. So if I press this button, then what do you think will happen? So try to guess. You see that in the command line we got by printed out. So this function was executed. But if I replace that with the exit function, which is a Python built-in function, see what's going to happen now. So if I run the program, so run the program again and close the program using that button. This time by is not printed out. That is because this line is never executed. So the difference between the break statement and the exit function is that the exit function stops the program completely. So as soon as the interpreter executes exit, then nothing else is executed. In contrast, the break statement only stops the while loop from executing again. So when the interpreter executes the break statement, only the loop is stopped, so there are no more iterations in the while loop, and therefore the interpreter goes and prints anything that is outside the while loop. Now your question might be, should you use break or should you use exit? The short answer is to just use break because it makes more sense. So you want to break the loop in this case, and if you want to do something else in here outside the loop, you can do so. So the break statement allows you for better control of the flow of your program. So you are allowed to execute other things between the while loop and the window.close method, while the exit function just exits the program completely. Right, that was about break. I'll delete that to leave the code as it was before. And the other experiment I wanted to try is related to the layout argument. So in our case here, we are supplying this list directly in here in the argument. So the argument is equal to its value, which is a list. But it is also possible to store the list outside somewhere in here. So before you create the window instance, you could first create a variable layout, for example, and that is equal to that list. And then in here you specify the name of that variable, and that would do the same exact thing as it was doing before when we had the list in here. And again, you could ask, what's the better solution here? Should you define it here in a variable first and then put the variable here, or directly the list in here? Well, feel free to use either version, so there's no right answer here. However, this method of defining the variable first could be beneficial when you want to dynamically construct the list of widgets. For example, let's suppose, let me type in something here. You don't have to type this in, so I'm just typing in and deleting it. So let's suppose that you had a list of button labels, you know, just a list of strings like close, apply, and the list could go on. And you wanted to create a button for each of those labels. In that case, you would want to iterate for BL, for example, in button labels. So you iterate over those strings, and then above here you would say layout is equal to an empty list, and then you append widgets, for example, sg.button with BL as the first label. And so this for loop would generate a layout list of lists, which would look like that, right? And then you'd supply that layout variable in here. So in this particular case, we would end up with a layout which would look something like, you know, SG button close, comma, SG button apply, etc. So each of those is a button instance. So that would be the layout variable. Yeah, I hope that's clear. So this way you can create dynamically a layout object, which is just a list, by the way. So it's a list of lists. It's not any special object. But in this case, we don't need to dynamically create a layout, so we could directly supply the list in here. So I just wanted you to know that with variables you are very flexible, so feel free to use intermediate variables, as I just did here. So layout was a so-called intermediate variable. You define it there and then you use it directly somewhere else. And these are the two tests I wanted to make. Let's move on with some more content. See you. Hey, welcome back. In yesterday's bonus example, we built this GUI. This is just the interface of the file compressor. So today we're going to actually implement all the functionalities of the program, which is that when the user selects the files and they select the folder, when they press compress, we're going to compress their files to create a zip file. Let's do that. So what we need to implement first is the while loop. We need to read all the time. We need to read the event and the values, which are equal to that. So let's see what we get with event and values. Let's run the program. So let's choose some files and see what happens when we do that. So A and B. Let's choose a folder such as that. Here, press compress, and let's see what we get now and analyze what we can do further. So when I press the button, we got the compress event, so that's the name of this button. So that means a compress button event happened, so the button was pressed. And we also got this from values. So the variable values is equal to this dictionary. This dictionary is made of this key and that value for that key, and also this other key and that value for that other key. So you see that the key choose, which points to the first button, this button here, contains this list of files, file paths. So that's an absolute file path of the a.txt file, which I selected as a user, and also the other file b.txt. We also have another pair of key and value. So one is the key and that is the value. That is the directory. And then we have this choose 0. So we had choose and choose 0. This points to the absolute directory, the destination folder, which I selected using that second button. So we have a dictionary of 4 pairs. As you see, this value here, which points to the 0 key, is the same with this value here. So we get 0 from the input widget. So the input widget has this value, but also the choose widget, this button, has the same value. You can also remove this widget. If you don't like, you can remove the input widget. But this is a common practice to show the paths of the chosen files in a text box. However, I wanted to tell you that even if you don't have this, things will work. So now, let's close this. And now we know that we can get... Let me close the program. We can get the file paths using values choose. So the key of that pair values is the dictionary, and that key will give us this list of file paths. However, note that this is not actually a list, this is just a string, and this file paths are divided by this semicolons. So that character separates those file paths. Therefore, in order to extract the actual file paths, you need to do something here. So let's say that we have this string, right? That's a string. Let me remove this. Now a.split with semicolon there, so the split method is going to return a list. So it splits that string at the semicolon. And so we have this list of separate strings. We have 2 items in this list, the first file path and the second file path. So now we have a structured data object, which is a list, and we can do further operations using that. So A in our code is file paths, so we can apply the split a semicolon, right? And that will give us a list of file paths. Now let's also get the folder path, which is equal to values. This would be choose 0, so that should give us, so this key should give us the string pointing to the destination folder. We can improve this because I think this is not so readable, the code is not so readable. So we see that values choose doesn't make much sense. So I think we should be using keys here. So we go to the choose button, and here we add a key argument, which is equal to files, for example. And for folder, we could say key equal to folder. So we're working on the folder browse and files browse objects. And then we can write here files and folder, because you'll see that if I run this again and I select 2 files, I select a folder, whatever folder it is, I press compress. Now you see that the key changed from choose to files. So that's better because the folder key also changed from choose 0 to folder. So this is more readable, and clear. It's better to use keys rather than letting Python use the name of the widget, the label of the widget as a key implicitly. So it's better to be explicit. Let's terminate this. What's next? Well, now that we have the list of file paths and we have the destination folder, now it's time to actually create a zip file out of those file paths. So let's do that, and it makes sense to create a separate file. So a Python file, let's call this zip creator. So zip creator.py, and you do remember that we used Shuttle, the library which was used to create a zip file. We did that a couple of days ago in the standard libraries. However, Shuttle is not as powerful as the zip file standard library. So for this lecture we're going to use zip file. Zip file gives you more flexibility to work with zip files. For example, Shuttle is limited. It asks you to specify the name of a file and then the name of the compressed file, but it doesn't allow you to select any folder where you put your compressed files. So zip file is much more flexible, and that's what we're going to use. So let's create a function make archive, and this function is going to be called by this front-end interface. So the function will get a file paths argument and a destination directory argument as well. So it's going to iterate over these files and create a zip file for each of them. So the function is going to iterate over these file paths and it's going to put them inside this destination folder. The way a zip file works is this. You say with zip file dot zip file. You see this is a standard library name, and this zip file is with capital Z and capital F, so that's a type. Now this creates a zip file type object. Just like we have file types, we also have zip file types. The open function creates those generic files, but now this zip file type creates these more specific zip file types. This expects the destination directory as input and the modes. In this case, it's write mode. We are creating a zip file. If you wanted to extract an existing zip file, if you want to extract its files, then you'd want to write read here. But now we want to create a new zip file. Let's create a variable as archive or as file, whatever you prefer. And then we iterate for file path in file paths. And then we point to archive, which is that variable which represents the zip file object instance, dot write. So that type of object has a write method, which expects the file path. So each file path of the file paths list. That's about it. Before we connect it to our interface, we want to test the function. So I'm going to create this if name is equal to main. I've explained to you what this does previously in the course. Actually, it's equal, not an assignment operator. So this basically says that if this script is executed directly as the main script, then we want to call the function. Otherwise, if this file is imported from another file, then this will not be executed. This line will not be executed. So make archive file paths. Let's type in the list manually. So I'm going to create that file path here. Or you can just provide some local files. For example, this zip creator file is in the same directory with bonus1, bonus2, etc. So I'm just going to provide some Python files here. bonus1.py. I can just write the name again because zip creator is in the same directory with those files. Bonus1 as a string, comma, another set of quotes, bonus 2.1.py, 2.1.py, like that. And the destination directory is going to be a folder inside bonus. So this can also be a relative. So this folder is going to be in the same directory with zip creator. Let's call this dest. So dest and zip creator are inside bonus. Therefore, I can just write here dest, the name of that folder, and run this file. Now let's take a look at the error we got. This is saying that it's a directory error, which means dest is a directory. This one in here. And that's true. So dest, this argument here should be the path to the zip file that will be created, not the path to the directory. So we need to do something here. We need to say dest dir plus backslash plus the name of the file, which is compressed.zip, right? But a better way to create a path is to use the Python pathlib standard library. So you don't need to install this library, it's already available in your Python installation. So the way it works is this. You can create a new file path. Let's say a is equal to pathlib.path. If this was dest, and then you say compressed.zip, what a is going to be is this path. So this path type is designed to get several arguments and merge them to create a complete path. As you see, it added this slash. In other operating systems, this slash could be a backslash, so this is intelligent. This type is intelligent. It knows how to concatenate different parts of a path to make a path which works on that operating system where the code is running. So therefore we need to construct a destination path which is equal to pathlib.path. So we need to import pathlib here, import, and then we use it here, and the path will be dest dir, which represents this dest, comma, let's give a name such as compressed.zip. And then in here you can provide dest path, just like that, and run again. Process finished. So we should see now the compress file. If I go to dest, yeah, that's the file. If I open that on my file system, I double click it, and those are the files I compressed. So that is a zip file. And that's how the function works. So this was a good demonstration, I think, to show you the way you create backend functions. So you create the function and then you can test it using this block here. So you wrap it up and inside this if name equal to main object. Now you know that this is working, so it gets a list as input for the file paths, and then it gets a string as input for dest_dir. So we go to bonus 16, and first we import from zip creator, or you can say import zip creator and then point to zip creator, but this is also fine. Since the file contains one function only, we can just import that one function. So it was make archive, and then now we have file paths, we have the folder, and we say make archive file paths and folder, right? File paths is the first argument, yes. So that variable is going to go in here and it's going to replace that one, and it's going to be used as a value. So that's the actual list, and the folder is going to be used as the destination directory. And now we're ready to test the app, so let's run it. First I'm going to see to make sure I have some empty folders here. So my files, yeah, this is an empty folder, and in downloads I have these files I want to compress. So run bonus 16, select files to compress A, B and C, press enter, select destination folder, that empty folder, press on choose, press on compress. And let's go to the destination folder, which was in here. So compress.zip was generated successfully, and now we see a problem here. So the entire file path has been included in the zip file. You see that the full file, the absolute file paths of this files was something like users, as, downloads, etc. So we don't need these subfolders. Therefore, we need to fix this issue. To fix it, all you need to do is go to archive.write in your zip creator file and provide an arc name. This should be a string now, and it's going to be filepath.name. What is filepath.name? Well, filepath is a path in that file paths list, right? So if I show you the console, we had this pathlib object. Now file path is currently just a list here, right? For example, is the path to this bonus1.py, or it could be an absolute path. But just like we did for dest_dir, we also need to convert each file path to a path special object. So we override that variable using this file path. So basically what we're doing is this, yeah, we have this file path here, and then we say file path is equal to pathlib.path file path. That's what we do. So what we get now is this specific instance. So before we had just a string, a plain string. Now this is a more specialized type of object, which is better designed to work with paths. So POSIX path bonus1.py, and file path.name extracts only the name of that path, because you know, if the path was like longer, for example, users, in my case it was as downloads a.txt. So if the file path was an absolute path, now file path.name gives only the file name. So that's exactly what we're doing here. We provide file path.name, so we extract only the file name from that file path. And we actually need to do that under the loop, so as soon as we iterate, we do that and we extract the name from that. Stop the program and let's go to bonus 16 and run again the GUI. So choose in downloads these 3 files, then choose the destination folder, and here my files, choose compress. Now I go to that destination directory, and that's the compress.zip file, which has replaced the previous file which was here already. So if I compress it, you see that now all these files are just inside this compress folder instead of being inside a whole path of subdirectories. And just before we close the video, we want to add one more feature. We want to add here a message, compression successful, telling the user that the compression was successful, so that the user knows that something happened and they can check the files on their system. Otherwise, without a message here, it can be confusing for users. So let's add that label in here. So we're talking about adding the label next to the compress button. And we're talking about a label, so that would be an sg.text instance. The instance is going to be empty for now. And then we're going to update that with a value. So you can either just place an empty string like that, or just leave it empty like this. Either way, it would work. So we store that into a variable, and then next to the compress button in the same list, we add that output. Let's call it output label to be more clear. So output label here, output label there. And then once we make the compression using the make archive function, then we want to update the widget of the window which has as a key. So this widget, it doesn't have a key yet, so let's add a key, let's say output. So our new label widget has this output key, therefore we access that widget using this expression. So this thing here now is the actual label widget. It's empty for now, but once this executed, then this will also be executed, updating that widget. So dot update, the value is going to be compression completed. So let's run the code, select the files to compress. These are the input files. Select the folder, this is the output folder, the destination directory, compress, and we get this message, compression completed. If you want a different color for this, then you will have to add a text color argument to the text instance. So you can say green. And if you run it now, your text will have a different color. And that marks the end of this video for today. Thanks a lot for following, see you later. In the previous days, you learned how to upload your code to GitHub. Today you're going to learn how to do the opposite, so how to get code from GitHub and copy it on your local computer. This is usually the case when you want to get code from other people repositories, so you want to use that code, you want to download it on your computer. So for that, let's search for a repository. You can search for Arditsulcha teaching GitHub and then go to the first results. So that will point you to this account. So you want to click there and then look for repositories on the repositories menu here. And you want to find the My To Do app repository. So you want to click there, and let me tell you now how you can get this code to your computer. There are two ways. One way is the manual way, which is by going to this button, code, and then go to download zip. So that will give you a zip file with all these files inside, and then you can extract that file and then open a PyCharm project and paste your files there. That's one way, but a more professional way is to do cloning. So a Git process known as clone. So you clone this project to your PyCharm IDE. Let me show you how to do that. So go to PyCharm, and if you have a project open already, then you should go to Git clone. Now you'll only see this clone option if this current project has Git enabled. If you have a project, for example, this other project, this has not been enabled for version control. In that case, you should go to VCS and then go to Get from version control. So either way, whatever way you try, after you press clone or Get from version control, you should see this window. Now, this is the URL of the repository, the remote repository which you want to get. It's important to know that you'll only be able to get public repositories from other people unless you know their credentials. So this is a public repository, so you can go to code and then HTTPS and then copy that URL by pressing this button. So once that is copied to your clipboards, you want to go back to PyCharm and paste it to the URL box. Now the directory. You should find an empty directory among your projects. For example, I'll go to projects. And inside this directory now, another directory will be created. If I press clone though, I'll get an error. It says the directory already exists and it is not empty. That is because this projects folder, which is this one here, already has this My To Do app folder. And I'm having this issue because the repository is also called My To Do app folder. So that means I should either find another directory where there is no such a folder inside or delete that folder. So I deleted that folder and then I go to PyCharm. So again, users AS Dropbox projects, press on clone. And then you want to choose whether you want to simply browse the code. In that case, you want to just press on preview and save mode. Otherwise, if you know what you're downloading on your computer, you should press on trust project. So trust projects should download the code on your computer and you should be able to execute the code if you want. Then new window or this window will close the existing project. New window will open a new window. It doesn't matter what you press here. I'll just press on new window. And then you should normally get this pop-up window. Now, if you look closely to this repository, you'll see that there's a requirements.txt file. This is a special file which I'll explain later on in more detail. So this file was uploaded by the person who has this repository, which happens to be me, and I'll also show you how we can upload this file later on, because this app is actually an app we're going to build in a couple of days. So this is a web app, a to-do app, but it's a web app, it's not a desktop app. So this requirements.txt file contains the list of packages needed by these Python files. So these are the modules, the third-party modules, and I've listed those packages in this file. And now PyCharm has detected this requirements.txt file. So this is a convention. Usually you always want to name it requirements.txt file. So PyCharm has detected this file and it's asking us if we want to install the modules which are located in here. So you want to say OK, and here you have the base interpreter, so 3.10 in my case, that will be used to run this project, and that's a path to the virtual environment. So you want to press OK here. And that should now install all those packages, so this might take a while. And so the third-party modules were installed successfully in my case. Now, if for some reason you don't have these modules installed, you can click on web.py. You should see some red underlines. That means these modules were not installed. So if PyCharm didn't install those modules, you can go to the terminal. You should see this venv, which means the virtual environment is activated, and then you should do pip install -r and then requirements. You can actually press tab to autocomplete the name. So requirements.txt and press enter. That should install those modules. So in my case, PyCharm installed them because I got that window which asked me to install those modules. But if that was not the case, then this is another way to install them with pip. Right, now that my modules are installed, I can go ahead and run this app to see its output. Now this is a web app, and as I told you before, we're going to write this web app from scratch in about 2 days from now. But anyway, I can show you how to run this. So with web apps, you cannot simply right-click and run the files. You want to go to the terminal and you want to do Streamlit. Streamlit is the third-party module which is used to develop this web app, and you want to do run web.py. Press enter. You should wait half a minute or so the first time you run it. So web.py is the name of this file. That is a file we are executing. But the way to execute it is a bit different, as you just saw it with Streamlit run. And that's the app. So the app opens on your browser. This is running locally currently, so it doesn't have a public URL just yet, but I'm going to show you how to make this public so everyone can visit your web app in 2 days, as I already mentioned. So that's how you can clone a project which is a public GitHub repository. So this repository now is also connected to a local Git. You can click on Git, you can see the commits here, which the author did when they developed this app. And if you want to create your own GitHub repository where you upload this app, you can do so. So for that, first of all, you want to go to your GitHub account and then create a new repository, put a name for that, my new to-do app, for example, make it public or private, and create a repository. And then you want to copy that link, so copy it, and then you want to go back to your project. So that's a web app we cloned. And then you want to go to Git, go to manage remotes. So what I'm doing here is I'm adding a new remote. As you see, that is a remote of the person who wrote the app. And you cannot push the changes to this repository because it's not your GitHub account. So you want to add a new repository which is part of your own GitHub account. As the name, you can place here anything you want, for example your name, and then the URL goes the repository I just copied when I just created this new repository on my account. So press OK, press OK there again, and then to upload this project to that repository which we just created, you want to go to push, and then you want to press on origin. So origin is one of the remote repositories. You see origin and ardit. So if you press on origin, you should be able to change it to the other repository. So now all these files are going to be uploaded to that repository on your GitHub account. So I got this message, pushed master to new branch, and if I refresh, I should see the files in my repository. In my case, it happened that both the repositories were in the same GitHub account, but it doesn't matter. So as long as the original repository was public, I could clone it on my PyCharm project, and then I can create a new repository where I have access to, for example, this one, and I can upload it back to that. You can see that the commits here were synchronized with the commits of the original author, which was 7 days ago. So these are not my commits in this project. These were the commits of that original project. Yeah, with that, I thank you for following this video. So now you know how to clone projects, and I'll see you later. See you.